Good day, Bayaw. Today, we have here another problem to solve from the book of Thermodynamics by Singal, Chapter 4, the first law of thermodynamics. A piston cylinder device whose piston is resting on top of a set of stops initially contains 0.5 kilograms of helium gas at 100 kilopascal and 25 degrees Celsius. The mass of the piston is such that 500 kilopascal of pressure is required to raise it. How much heat must be transferred to the helium before the piston starts rising? First, we're going to identify the given. We have here the mass of helium gas that is equal to 0.5 kilograms, the pressure 1 that is 100 kilopascal, pressure 2 500 kilopascal, temperature 1 25 degrees Celsius, and this heat that is transferred to the helium gas. Here is the solution. We have here the equation energy input minus the energy output is equal to the energy change of a system. And since our system is stationary, the changes in potential energy and kinetic energy are zero. That's why we have this equation here, the Qin is equal to the change of internal energy, that is also equal to mass times the specific internal energy at point 2 minus the specific internal energy at point 1. And since this equation here, the U sub 2 minus U sub 1 is also equal to CV times T sub 2 minus T sub 1. So we have this final equation here, the Qin is equal to mass times CV times the final temperature minus initial temperature. And since T2 is missing, the final temperature of helium can be determined from the ideal gas relation to be this equation. P1 times V over T1 is equal to P2 times V over T2. And we will be having this equation here of the final temperature, that is the final pressure times the initial temperature over the initial pressure. So we will be plugging in the values. We have here the P2 that is 500 kilopascal times the T1, the 25 degrees Celsius plus 273 Kelvin over the P1 that is 100 kilopascal. And here is our final temperature, that is 1490 Kelvin. And since our equation here has this CV, we will be using our property table to be found in table A-2, that is here in helium. We have the CV here that is equal to 3.1156. And since we have all these values here, so we will be using this our final equation, the Qin is equals to mCV times T sub 2 minus T sub 1. And we will be plugging in the values, that is equal to 0.5 kilograms times 3.1156 kilojoules per kilogram Kelvin times 490 minus 298 Kelvin. And we have this heat transferred to our helium gas that is equal to 1857 kilojoules. And this is our final answer.